Hi people, this is just a short video to take you through how to do the flex work. Okay. The key thing with it is just the language. Okay. Explaining what the words mean and how they relate to what we study in class. So series is just adding a sequence. So with these, evaluate each sequence related to the arithmetic series. What you're doing is you're just adding them up. So you can do that on your calculator, or you can do that using the formula. So just do 5 plus 10, 15, plus 15, 30, 50, 75, 105, okay? All we're doing is just adding them up. Next, for these 4 questions, there's a little bit more to them, okay? There's a new piece of terminology, and this terminology is called sigma, okay? So all of this here is sigma notation. And what it means is add from term number 1 on the bottom to term number 18 on the top for the sequence that's expressed in this formula, okay? So I've got to work out the sequence of this formula and add the first 1 to 18 numbers of it. So in order to add this sequence, I'll need the first number, or A. I'll need the common difference. I'll need the number of terms in the sequence, and I'll need the last term, or to use my formula, Sn equals 2a plus d outside of n minus 1. Okay, so let's get started. Okay, in order to use this to work out the formula, to work out the first number, what I need to do is pretend that n is 1, because here n is 1 in the first number. So 1 times 3 plus 0 equals 3. In this one, it'd be 9, take 4, lots of 1 to find my first number. So this is going to be 5, 9, take 4, lots of 1. So in 6, a is going to equal 5. And in 5, a equals 1 lot of 3 plus 0. So that's 3. So here, our a equals 3. Okay, here our d is the number in front of our n, because that's the times part of this sequence. Okay, so each time the number's going to go up by 3. 3, 6, 9 is an arithmetic sequence going up by 3. So in our 5, the common difference is 3. Here, we've got minus 4n, so our common difference equals minus 4. So, number of terms we've got to add up, 18 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 terms, okay? So our number is 18. The terms we've got to add. Here, our number is 10. So n number of terms equals 10. And with that, we chuck it into our formula. So I'll do 5, and you can do 6, 7, 8, and 9. Okay? For 5, what you do is, put the wrong formula up here. That's terrible of me. Sn equals n over 2 outside of 2a plus d outside of n minus 1. Sorry about that. Okay, you do need to times the number of terms in order to use the formula correctly. So now we can go 18 in our n position over 2, which stays the same, equals 2 times 3 plus 3 outside of 17. Okay, and we do that on our calculator. 9 times 6. Cool. That should equal 486. Excellent. Okay, next. Determine the number of terms for each arithmetic sequence. Okay, this one is going to take some thinking. Okay, and after a lot of thinking, you might come up with the formula that we used for adding an arithmetic sequence, which was Sn equals n over 2, our first number, or A1 plus An. Okay, first number plus last number, A1 plus An. Okay, and here they've given us A1, our first number, An, our last number, and the sum of the sequence. So if we were to chuck these numbers into that formula, we could go 64, our sum of the sequence, equals n, the number we're trying to find, on top of 2, outside of 1 plus 15. Okay, so we get n divided by 2 times 16 equals 64. Okay, so 64 divided by 64 divided by 16 is 4, times 2 is 8, so we're left with 8 terms in the sequence, because 8 divided by 2 is 4, times 1 plus 5, 16 equals 64. Cool. Here we're just determining the common difference. So is there a common difference, and what is it? And in our first one, we just go minus 32 divided by 16, which equals minus 2. 16 divided by minus 8, which equals minus 2. And minus 8 divided by 4, which also equals minus 2. So our answer is yes, and it is equals minus 2. And common ratio is minus 2, and yes, it is a geometric sequence. Here we're trying to find the first 4 terms. Okay, so we're given a formula. Okay, and this is how we use that formula. Term 1 is 4 times 5, and we replace our n with 1, so we get 5 to the 0, which is 1. So we get 4 times 5 to the 0, which is 1, so we get 4. Then we get term 2, which is 4 times 5 to the 2 take 1, which is 5 to the 1. So 4 times 5 to the 1 is 20, or 4 times 5. Then we get term 3, okay, which is going to be 20 times another 5, so that's 100. Term 4, which is 100 times another 5, 500. Okay, and we're looking for time 5, which is 500 times another 100, so that gives us 2,500. Okay, now that's the first 4 terms in the sequence, replacing n with 1, 2, 3, and 4, and then I also found the 5th one, because that's what I was told to do there. Finally, we've got to find the common ratio, and the first term, we've got to use those things to find the... So our formula for the geometric sequence is Tn equals A times R to the n minus 1. Okay, so we just replace our 5 and 2 with our A and R, and we're left with Tn equals 5 times 2 to the power of n minus 1, because for the first term, the n and the 1 cancel, and we're left with 5 times 2 to the 0, which gives us 5 times 1, or 5, and keeps the first term 5. And then we just go 5 our first time, times 2, which equals 10, times 2, which equals 20, times 2, which equals 40. And that's our first 4 terms and our explicit formula. And that's everything. If you've got any questions, queries, or problems, don't hesitate to ask, and I will talk to you soon. Bye.